You're right. Yeah. Now we're on air.
Cool.
But just about the not the details about the project, but is it like a long-term project, or do you have like a
Yeah,
deadline?
definitely. So this will be going into production hopefully end of the year.
Cool.
Yeah.
Cool.
Used
Looking
by
forward to follow it.
so used by lots and lots of customers around the world.
Mhm. Awesome.
So if it doesn't work, we'll know about it. That's for sure. Okay. So what I did have some basic notes here. Let me just find those. Okay, so I thought I'd start with the state model.
Mhm.
Then we'll go into the signals and views, and then I'll show you some crazy stuff that we're experimenting with, um, and then just some basics why we've found TypeScript very beneficial in our type of project. So if I go to the state model itself. So I suppose, like, do you know about interfaces in TypeScript?
I'm not kinda, yeah. Though I'm sure
So
I've
all I
been.
do is represent a structure that needs to be adhered to. So if something matches this structure, e.g. it has an expense property, a Windows property, transactions property, etc., then it's seen to be conforming to this interface.
Yeah.
Okay. So what we've got here is we've got this iAction context. So that is, you should know that when you see it, which takes the input, state, output, and services. And so the state is just an iState model, which is, if I navigate to that, I suppose there's the first part of TypeScript where you can go directly to the actual definitions or the implementation. We've implemented these based on the documentation from the website and the code.
Cool.
So this is just a definition file. This tells TypeScript what or the type system in TypeScript what it should expect.
So this is
But in
like
the end,
something other people
all of
could.
these types get erased.
Yeah. So like other people who wanted to combine TypeScript with Cerebral can get this file, and then they will get some tooling and discovery, like lookups out of the box.
Exactly.
Yeah.
So I've mapped out most of the surface area. So I'll try and put these up on to the place where the typings go for TypeScript in the next couple of days, and then we can iterate on them from there.
That's awesome.
So going back to the state model.
Because that's like a central place where you can kind of like fetch different.
Exactly, it's like NPM, but
Yeah.
for typings.
Cool.
But it's much better to put it on a package itself. So when
Yeah,
just
exactly.
if you npm install package,
Okay.
it defined in packages on, it just works without special place to go to
Cool.
get definitions.
So yeah,
Yeah,
the
we can do.
definitions are separate, but for most of the things, so you kind of get used to that anyway. But yeah, they're going to be packaging them with it
Yeah, but
coming up.
we can give you access to the repo, Adam, so you can iterate on it directly in the repo as
I
well?
wouldn't to hurry on it, because since you publish DTS files, it becomes a public API as well, and any breaking changes there would require a major.
Okay.
And
Yeah.
it's easy to write DTS files in incompatible way, still working for the same code. So let's explore it separate for now.
Yeah. Okay, cool.
Yeah. I'll just they can just live somewhere, and if people want to pull them in, they can pull them in, and we can just iterate from there, even if they live at a repo, a separate repo for now.
Awesome.
Yeah. So what we're doing is we're modeling our whole state tree with strong types. So we've got the concept, expense, windows, transactions, etc. And if I head to like the expense one, that's then another model which goes deeper.
Mm-hmm.
Okay. So anytime that we go to obviously use one of these, we'd want to get the path out. So I posted a few weeks back about how we did that.
Yeah, because that's really interesting how.
Yeah, and this is this bit is kind of a bit magical in a way, because you're representing a path as the actual property type. Okay, so it does give you, in the end, it compiles to a string, but it gives you the it looks like it's actually you're accessing the property directly. Okay, so if I head to, let me just check what I. Yeah, so I'll go straight to a view because that'll probably make it a bit clearer. Okay, so for us, what we also do is we have this, all the signals are typed as well. So right through the whole thing. So we've got this type called props signals, which is this signals interface as well, which has all of our signals, and they're all typed as well. So they have the name and the properties that actually need to be passed in to them. Okay, so the benefit for this is when we're going to a view, let me find one, it's easy. Okay, so for instance, so we've got this helper called getPath, which if you look at getPath just takes our state model, it knows that it's a state model, and then returns an any array, which it returns, no, that's args, sorry, and it just returns it returns the actual type of the property. So what this gives us is, firstly, if I remove this line, this errors and says, argument, you haven't met the interface that goes with props, and props is defined as a window ID and a window. So window ID gets passed in, and then we convert using the window ID to get the actual window out. Which I think most people, that's how they're using that functional part for connect. But usually in here, what you would do is you would have window is equal to some string where you say window dot whatever,
Mhm.
and then bounce in props.windowID, and then keep going.
Mhm.
So what we can do with this is to go, if I remove this part and just say, so you'll see straight away I get my state model.
Oh.
Does that pop-up come up?
Yep.
Yep. So this is my entire state tree. And I can go in here and I can go further, and I can look through here, go to notes, etc. It also has what type they are on them,
Cool.
and those types have to match. So if window here is expecting a, what was window expecting? It was expecting a window state model,
Mhm.
but I say just give it an expense. It goes, no, don't like that either.
Hmm.
So I have to give that a window. So for that, I need to go to the active windows, and then we did this little trick where we use the array syntax as like, so you know if you're doing like a string dot format, you would use like 0, 1, 2, 3, 4, etc. for the, you would create a string and then you would have placeholders.
Mhm.
These array syntaxes are basically placeholders for the second arguments.
Uh-huh.
Okay, so
Mhm.
this will eventually look up whatever that, so this 0 is only important because this is the first parameter.
Okay. So it's okay. So the 0 will be replaced with whatever is on props.windowID.
Correct.
Mm.
So this will end up generating the string windows.activeWindows.0 dot the window ID.
Cool.
But as far as this is concerned, all it knows is that I've got that strongly typed thing.
Huh.
Which means that also when you're in here and you say this dot props, you get the window, which then has all the window details on it. If I type one wrong, it's not there, it doesn't work. So you get that. Also with signals, remember I said that signals were strongly typed all the way through as well.
Mhm.
So I can do this dot props dot signals dot, okay, I want to call a Windows signal. Sorry. Windows. Then I want to close a window.
Hmm.
And then you go, okay, what did I need to pass to close again? Can't remember, so I'm going to have to go back and look it up. But here you don't have to because it tells you that it's an action input. And if I start to pass it and I do control space, I will get window ID here.
Hmm.
So I know that I need to pass a window ID. And if I pass it as a string, if I pass that as a number, it goes, nah, don't like that. Needs to be a string.
Yeah. Huh.
Okay.
That's pretty cool. Is that though like in terms of like API surface change? Is it only the get path function that's required to make it work?
Yeah. So to get the signals bit to work is just through this props signals.
Mhm.
So all that does is that is a base type that has it inherits this I signals interface, which is just signals of the T signal model, which is your base signal interface.
Mhm.
And this is that implementation of that get from path. So it basically converts the function to a string and then rips out the parts that it needs. and replaces the arguments. So along with that, we also, and in terms of props comes through from this as well. So, and they just get hooked up by the fact that, that's just straight Cerebral there, yeah?
Mm-hmm.
This would get compiled to window with the string of the path.
That's really interesting. Would it be like if we said that it's possible to, like, now you have to put a string or an array as a value, like the path.
Yep.
But if we allow that to be a function instead, so you wouldn't have to call getPath, you would just do X arrow function and the thingy you do there.
GetPath is where the magic happens because it needs to convert that to a string.
Yeah, so I thought maybe that could actually be, like, at least technically, it could be part of Cerebral so that you didn't have to call it.
That would work. As you would have to specify your state model here, though.
Oh, okay.
So it would be like that. So all I've done is wrapped GetPath so that, because this is in my project, there's two parts to this. So if you look at the actual GetPath itself, it does this path from model for state model.
Oh, okay.
So this path from model is what could be in Cerebral.
Okay.
And then you would just set up, this is just a shortcut helper so you don't have to specify the model every time.
Cool.
The other part to that is this combined path one, which is what we came up with the other day to kind of do this shared thing where you could reuse a component. So let me just find one of those. Yeah, here. So at the bottom here, we take the coding path which gets passed in, which is of type coding state model, and then you pass it directly to combined path, which then you can chain, and then from there you get IntelliSense for its children.
Ah, okay.
So in our case, everything below this coding path will be static to that module or component. And so this is kind of the dynamic part, and this is the bit that is always relative to whatever the coding path is passed in.
Just to be one thing, like here, there's a different example of you have props.segment key. Just so I'm sure that I understand, is that kind of like concatenated to after segment ID, or is it?
No, it's replaced with the 0.
It's replaced with the 0. Okay, yeah, just so I'm sure.
It would end up being dot and then whatever the segment key is right here.
Yeah, exactly. So it's just a typical using brackets to insert a variable to dynamically look up a property, but yeah. Okay, cool.
And because you're using the array syntax, it actually works really nicely. So if I had, say that state was an array as well, then I would say that would be 1, and then I could pass in, something here as well.
Yeah. But if you wanted to be like hard-coded 1, you would just use 1 as on the right side as well.
If you don't pass this in here on the right side, then it will just do 0.
Okay, yeah, cool.
So if you wanted 7 or whatever, then it won't replace it.
Yeah.
And we've found that works really well because that's also now typed. So if segment ID, if you can see the type on the right-hand side returns a number, and so does segment ID here. So if I tried to, instead of segment ID, I got freeform value,
Mm-hmm.
then everything blows up.
Hmm.
And if I bring out the error list, you can see that it says, this is not assigned, property segment ID is not assignable to blah.
Mm. I'm just thinking here what we also could do with this kind of project is to have like a Cerebral Typescript kind of project where we have the typing file and these helpers. That's also
exactly.
an
I was
approach.
referring to before, having a separate repo for that.
Yeah, because then you kind of you opt into TypeScript and then you get what you need inside that package.
Exactly.
Hmm.
Yeah, so for us, this gives us complete. So our views, if anything changes, then we can refactor it. If I go and change a property on the state model, then it'll break everywhere I'm using that property,
Hmm.
Which is really, really cool.
Yeah, that's.
If I change segment label here, segment label 2, then it's going to blow up everywhere where segment label was used, which is here.
Yeah. I'm really impressed that because that was my biggest concern using TypeScript. As I said, the project is older than when TypeScript became kind of like almost a mainstream thing.
Yeah.
So it didn't even think about using these strings as a problem, but you actually found a solution to it. It's really cool.
Actually, I couldn't believe that we actually could get it to work.
Yeah.
It's a bit of magic, like I said, because it's not actually returning that type; it's actually a string, right? But
yeah.
as far as the type system goes, it doesn't know.
Mm-hmm.
So yeah, you're kind of lying to the JavaScript, but what JavaScript doesn't lie to you?
Yeah. Good point.
The other, I suppose, a point while I'm there is if you want to come here and you want to change that because that was segment label 2, then you could rename that, and that would rename all the variables where that's used as well.
Huh.
So, and that doesn't do a find and replace match. That will go to every file which references it and replace them all.
That's awesome.
And yeah, you can control click to get to things and stuff as well. So yeah, I can rename that back, and it all goes back to normal.
I think this is the first time I've ever been excited about types.
Yeah, and for us, because we got our whole project in C#,
mm-hmm.
It's all types. You have to have types, and so going to JavaScript was just like, what the hell is going on? Chaos.
Yeah.
Another thing to note, we convert our server models to TypeScript interfaces.
Oh.
So that when we're posting to the server, we can't get that wrong either.
That's cool.
So that's another benefit that you can get. And most languages you can generate, types. So if you're using JavaScript on both sides, then you can just generate a type and use that on both sides.
Mm-hmm.
For us, we're using C# on the back end, so we take our C# model and then we generate TypeScript interfaces from that, which we consume in here. What else did I have? I've shown you that. So yeah, the signal. So one of the other. So obviously the signals is pretty powerful, but so probably the pain points at the moment are. If I go to one of these signals. Actually, I wanted here. Okay. So as I mentioned before, we generate all of our expense signals or whatever signals so that we can call them directly from any view.
Mm-hmm.
and they all have their input types as well, so you know what to pass to them, or in this case you don't have to pass anything. But the problem is when you come down to here, add signals takes an object which is expecting an array, but the signal is really a method call which is up here. So you kind of got this little bit of a mismatch. However, this is where the experimental magic comes along. So I'll just flick over.
Just a couple of things on that. Like it's really annoying. The only reason we have immediate is because React doesn't allow you to change the input value and then sync it back asynchronously, like Inferno, Snubdom, and all other libraries do. It's a super pain point, and it actually affects the API, and now it affects this, so it's kind of.
Well, it's not just this chain one, to be honest with you. It's all of these.
Oh, okay. Sorry. Yeah.
Yeah. But I'll show you how we've dodged around that a little bit. In this. But is there any questions about that stuff that I've covered so far? Like I said, we've got module here which has all of that stuff on it as well.
Cool.
Otherwise, I'll continue to where the gremlins lie.
Yeah.
Okay, so for us, one of the hardest parts was, actually, I'll just flick back. Given a chain, let me just find one that's fairly, something like this. We want to do this run rules thing. Now, this can get called in different signals. So we want to reuse it. The problem is that this takes inputs. So but we don't know that those inputs exist before we put this in here, right? So here we are basically taking an input or just creating an output from a state path because we need it for this one.
Oh, okay, yeah. So you don't grab it from the input, you kind of like grab it from the state store?
Correct, because so here we're just adding coding path to this input of the next one, basically. But it's not clear that to any of these if any of them take any input, it's not clear that what that input data would be. Because you don't know, right? Any of these could add outputs which the next chain relies on. So to solve this and to solve these, all taking sort of the same input, because really they do just flow down, right? The chain input is consistent, and all you can do is add extra properties right through outputs because you merge them. Is that correct?
Yeah.
Yep. So what we're prototyping at the moment is a fluent syntax for building these, where everything is guaranteed. So if I don't have my previous stuff, or if I don't fulfill an output, then it will error. Okay. E.g., we've got this modifying item. Now this, sorry, let me just go to that. It's just an example to show you guys, but it's modify item and it has this true result context. Okay, which means that output here can have a true or a false. And it's of type, if you look at the type of the input to that false, it has to be of type output.
Yeah.
Okay. So what happens here is that we just define this as a chain which takes a chain input, which we get from the signal itself, and an output. And so here I've just done some bogus logic to output both, right? When we go and use this here, and you're going through, what we've been finding is you do the first part, but you forget to handle all cases.
Yeah.
Or you're not actually sure what the cases are that came from the previous thing.
Mhm.
So if I comment that out, this breaks.
Hmm.
And it says that basically you didn't fulfill the contract that requires you to have a true and a false. Okay, so you can think of the whens at the moment, and these are bad names at the moment. We're still playing around with better names, but you can think of these as the ones that produce outputs that I need to handle. And the do's are kind of the standard ones that have no outputs.
Oh yeah. Okay. Yeah.
Okay. So what we're saying here is that when this happens, then we need to handle both of these. And all I'm doing for this one is console logging. But if you look, when I go into here and I do z dot, then I get full IntelliSense again on the input. For this one, there's no input, but that can work as well.
So the X there is kind of like the next chain based on the previous chain, kind of.
Yeah, exactly.
Yeah.
So if I comment out the then as well, this will error and say, well, you didn't do a then when you did a when.
Yeah.
Okay, so it means you didn't handle it at all.
Cool.
What else is pretty cool is we started with an input which just had nothing on it, and then we returned an output. So that should, in the next one, and if you look at the properties of the do here, you'll see that if you look over to the far right, input is now an I context of chain input and output.
Mm-hmm.
Which means that if I go here and say we've got this is the typical case in that example with the state using that state stuff.
Mm-hmm.
But if I rewrite that to use just a quick function, I will then get my state, which has all these. I can say set. I can say get path of my path from model, because I don't have the other one here. Path from model of my new item title.
Yeah.
And I'm going, and you'll see that in set the path has to be the same type as the value.
Mm-hmm.
So if I passed in a number here, that's not going to work. But I want to set it to empty, and so now we're all good. And you'll notice that also if I took in input here, and I went to here and just said input dot, now I get result.
Yeah.
And result is only available after we've gone through it. So if I took this and moved it up here, and now I do input dot, nothing's available because I haven't gone past the output.
Cool.
Now the other benefit with this is that this B actually returns, if you look at the return signature, it does a bit of that magic to return this func of x any to void, or an empty one, which means that we can come back, and let me just fix this for a sec. We can come back to our signal definition, which is here. And now I can say controller.add signals, core signals, and then I can wire them directly up and they don't type error now.
Oh.
So it means that if I miss one of these, I get an error. And these get wired up. And then I just created this immediate thing just before, about 2 minutes before the thing, to do a trick here where I return the chain input with the true, but then I just cast it as a T as if it was the type that I expect it to be.
Yeah.
And so you get this nice immediate blah, add new item blah, and all your signals are typed when you hook them up as well.
How do you feel about like when things get it? Maybe it doesn't matter if things get like deeply nested and stuff. It will just understand. Like for example, if you have maybe you're not gone to that level yet, where you have like two parallel actions running, where one action goes down one path, which has different inputs and outputs than the second parallel action, kind of.
It should work, because all the chain builder actually does in the end is take your signals and push them onto an array, and then return that array.
Okay.
So, but all we're doing is in the end, an array is returned in like the JavaScript, but the typings think we're returning a function that looks like a signal, which gives us the ability to also mimic like the true false here. It takes an input of T, which means that if we pass the wrong thing to this as well, then it won't work either. So if I forgot to build this or whatever, it says it's not the right type.
Oh yeah.
So yeah, in theory, in here you could then create a new chain builder, and you could just keep nesting chain builders, if that makes sense. So in the do, I could create a new chain builder here of chain input, and then do whatever, and build that, and then which would return an array, and then I could do another one.
Yeah. Huh. That's really interesting.
So yeah, it's not as nice a syntax as the straight arrays and stuff like that, but you get guarantees about things that you can't do with just passing functions randomly around.
Yeah.
It also means if I go to this add item one and say that I said that the context was a string, if I go back to here, this says, no, you can't pass me something that doesn't accept something that has a result on it.
Yeah. Huh.
So it means I can't transport these chains into places where the properties and the values aren't set up to run that chain.
That's really cool. And I haven't even run the code yet.
Yeah. And that's the benefit. You don't have to run any of the code to get some confidence that you haven't stuffed up. Like we did a big refactor the other day, and it worked first go.
That's cool.
Like literally extracted a module, a thing into its own module, and changed the state path that it was looking at. And so if we go and look at that example working, which is just the stock example, yeah. So it still fires exactly. And if we look at the scripties, And after you get through all the Webpack stuff, in the end it would get through to our which would just be, it would look exactly like it would look normally.
Yeah. Mm.
So that's sort of where, these are still doing the same thing. Props.title change, items just returns x.items, and that does our lookup for it. And yeah, it just works, but you've got the full type safety.
Quick question, Adam. Do you have to debug in the Chrome console, or can you connect the IDE as well and then debug there?
I think you can connect the IDE. We, to be honest with you, haven't really needed to do it that much.
All right.
I suppose that's the first guarantee you get with types is that you didn't call the wrong thing with the right, But when we have done it, because the TypeScript really just emits JavaScript and it pretty much is the same.
Okay, so you just read the compiled code and find your errors there.
Exactly.
All right.
If you build, you can build the TypeScript stuff with source maps, and then you'll actually get when you get the error, you'll get the TypeScript error and the file that it was in and what line.
Okay, cool.
And so you could then, you couldn't you can debug. We had some issues with it today, but yeah, I'm pretty sure you can debug it. But to be honest with you, it's not that much different that you would need to.
All right.
And yeah, that's pretty much it. Like I said, the refactoring F2 is awesome. Just being able to rename, and it renames across files and across usages. IntelliSense for discoverability of APIs, especially coming to a new thing like Cerebral and not knowing where things go. And
yeah, just like the state tree, that you can just dive into the state tree right from your where you are.
Exactly, and we've even mapped it back to if you go to the main here, this container knows that the controller is a controller of type iController as well. So if you don't pass this on here, it errors.
Oh, yeah.
It's simple stuff.
Yeah.
Most simplest of today's demo.
Yeah. But I suppose it's if you're not used to it, it's magical.
Yeah.
What about new connected signature? Connect signature with signals mapped one by one.
We could probably do that the same way we do the get path, and hook them up like that. To be honest with you, we like the fact that at the moment we don't really use it like that, so we haven't done it. If you wanted to fully isolate your signals, yeah, for sure, you could do that. You would just need to put a property on the, if I go to the example, it would look something like this. So given that you had another, does that take props in as well, does it?
Not yet, but it will.
It's just of this type, so you might have something here that did the same thing, so my cool signal or whatever, and then that could do the same thing and do path from model, of the, but instead of accessing that, it could access the signals, and then it would give you IntelliSense for that signal.
Yeah.
For instance. As long as you had the signal on here, so you'd have to have my cool signal, which would be of type, if it's calling nothing, then it would just be, like that.
How is it with, because now you're connecting and yeah, you're just using an object to define the state, the state dependencies, like new item title and items.
Yeah.
But what if that is a function where you return that object?
Okay, yeah, that was what I showed before.
Okay.
I'll bring it up quickly because it's important.
Mm-hmm.
Yeah, there you go.
Yeah, of course, yeah. Cool.
So we use this props in props thing so that the props that is called from the signal is kind of your props in, or like the external facing thing, and then props is kind of your internal one.
Mm-hmm.
And so our connect definition, we basically took the ones that you did the other day, Alexi,
Yeah.
but just modified them to be strongly typed here. So this second one is interesting because what we actually do is we say that the component has access to the external props, which is the internal one, but it actually returns a component that has the external ones so that you don't see any of the internals from a component when you're calling it.
Yeah.
So that works really nicely as well. So thanks for that.
Glad to help.
But yeah, like I said, the typings aren't very complex, but kind of, the hardest bit to get used to if you're coming from JavaScript will be that you've got to create types for everything, all interfaces.
Yeah, that was one thing that popped up in my head. How much time do you feel like spending on making things type safe?
Well, to me, it's not just about, I suppose, the person doing it right now. I don't know if, the projects that I've been in the past, creating the code's the easy part. It's the 10 blokes after you that have to maintain it.
Yeah, it's true. I mean, I get the benefits, but still, if you like in the beginning, it's still a lot of overhead, isn't it?
When I say a lot, yeah, you might spend half an hour at the start setting up your basic types for how you want your project to run. But once you've done that, it's pretty smooth because as soon as you start creating these components that take props in, yeah, it might take you 10 seconds or 20 seconds to type that out, but you save that when you go down to the view and you get full IntelliSense and event source type checking.
So you feel like it evens out right away.
Yeah, you get it back straight away. As soon as I come in here, I get props dot. Oh, actually, yeah, I want a segment key. Cool, done.
Yeah.
Not sort of having to context switch a lot and say, actually, what did get passed in here? Okay, I'll go and look somewhere else. Which I think is the biggest benefit, that you don't have to keep switching around files.
Yeah.
Because you get that type inference, you kind of get that for free.
Yeah.
Awesome.
Yeah.
So
I think pretty much it. That's pretty much it for me showing stuff. But yeah, if anyone's got questions or whatever, happy to answer them.
Yeah. Personally, I don't have any questions. I'm just really, really impressed. That I think this is, very, very cool. And what I suggest is that if you agree, Alexi, if we set up like a Cerebral -TypeScript kind of thing, repo, and then bring in the type definitions and these helpers, and then just move on from there and agree on what do we want to expose, and also as I understand that the chain builder is quite experimental.
Yeah.
But yeah, we can maybe discuss.
I mean, we could, maybe you could have folders where we've got like the definitions that we agree on, and then we have like an experimental folder where people can buy into things if they want to buy into it. If they don't, then
yeah,
they don't have to. Because it's not, for us, we're building a fairly large and complex. Like those screens that I showed you now is already where is it? Yeah, it's already 770 files.
oh.
And we're not even 20% in.
Yeah.
So imagine, TypeScript was originally built for Bing. So they had over 100,000 line JavaScript application for Bing Maps, and they couldn't refactor it at all.
Yeah.
Yeah, I think the bigger the project, the bigger the benefit, especially when it comes to refactoring.
Yeah, to be honest with you, if I was just doing a very simple, 5 to 10 components, very simple stuff, I wouldn't use it.
Yeah. Yeah, I think I agree on that. Yeah, I think it's really cool, but depends on the project. If the project is not going to be like big, and if you're not working with a team, and if it's just maybe like a short-lived thing, it's probably not worth it setting it all up, huh?
Yeah. So though, like once you get a template going, Webpack has its own TS loader, and the workflow doesn't change really.
Yeah.
But also, what we're actually doing is we're compiling TypeScript to ES6, and then Babel's compiling ES6 to ES5.
Oh, okay. Could TypeScript directly compile to ES5?
Yes.
It could, but we ran into problems with it.
Okay. And have you ever migrated an existing project to TypeScript?
We have, yes.
Is it
so every JavaScript file is a TypeScript file, so you can just start renaming them to TS.
And get a lot of warnings, and then go take it from there.
Exactly.
You can even get warnings if you set compiler option no implicitly to false, then it just work as is.
Okay, so you could just start refactoring parts into TypeScript and leave the rest like vanilla JavaScript. Okay, cool. Yep. That's pretty nice.
Especially with the new, when 2.1 or 2 eventually comes out, it will be able to compile JavaScript files and import them as well. So you could literally reference JavaScript files from your TypeScript application.
Yeah, that's pretty nice. I think that's like a really big benefit if you can just mix and match and pull in all other components as well, or modules as well, without adding any TypeScript definitions.
Yeah, for sure. I mean, if I look at the Webpack config, it's pretty simple. This is it here.
Yeah.
Is there like an overview of which parts of TypeScript? I think in the beginning when I read about TypeScript, they said they want to stick as close to the ECMAScript standards as possible. Is there like an overview which part of TypeScript is like ECMAScript maybe 7 or 8, or at least proposed ECMAScript features, and which is never going to be ECMAScript at all?
Yeah, they'll only take stage 3 proposals.
Okay.
So things like the spread operator for objects doesn't exist yet because it's only at stage 2, even though Babel supports it. TypeScript doesn't.
Oh, you don't?
No. So you get it in the TSX files. So you can do in your sort of React stuff, you can do the spread.
Yeah.
But you can't spread an object at the moment because, like I said, because the
it's not official yet.
Yeah, it's not stage 3 yet.
Yeah, they don't want to
And
introduce features that they might have to remove later on.
yeah, exactly. And also, how does that work with types when you're doing a spread operator of an object? So there's things that need to be worked out about what type should that produce.
Yeah.
Do you guys know about the current state of types getting introduced into JavaScript?
Oh, there is no plans about it, as I know. Only Flow.js.
Okay.
Yeah, I don't think there's any plans either. From my
There is little chances to get types in JavaScript.
Yeah, because it has to work on all the old code as well. So, like old, I don't know, yeah, like old, how does that work? Yeah, it doesn't have to work on old browsers, but at least on all. Yeah, I think it's hard to introduce the syntax.
yeah,
I think it's probably going to be more about like basic principles they have or they started with in saying like there's dynamic types and static types fractions, and I think they just really stick to the dynamic type of life.
as long as
Just
they
like-
introduce a proper number type, I'll be happy.
Yeah, that would help a lot, I guess.
Yeah, we're having to use big number at the moment because we do a lot of obviously addition, subtraction, currency conversions. It doesn't take long before you run into that floating point math BS.
There's one thing I think, like, because I saw that Alexa already started doing like the what module was it? I think the state tree.
Action tree.
Action tree, yeah. Sorry, the action tree in TypeScript, and I actually started like a small project where I needed the action tree parser, and for me at least, it was a bit harder to understand the code and to get into the project. And I think this could happen with like contributors as well. If you have an open source project that's completely TypeScript, I think you dramatically reduce the number of possible contributors due to people not knowing what they're reading or how to contribute.
Yeah.
You would say that the action tree source code is not pretty understandable from start?
No, I think it was understandable, but if I wanted to contribute to the project, I'd have to get a lot more into TypeScript than I am now.
Yeah. I suppose because I suppose we're in the sort of C# community, TypeScript is fairly rampant in that, and it's not a obviously Angular have taken it on as their main for Angular 2 as their main way. So it's pretty much mainstream now from where I sit.
It's the same with like the new ES6 syntax. There was this whole discussion about examples, code examples.
Yeah.
And yeah, there was this discussion we shouldn't show code examples with the new JavaScript syntax because people don't understand it. So I think we're like on the threshold now of well, it depends the adoption rate of TypeScript further, but yeah, definitely now you have a really good point, Max. There will be like this dropout of contributors because they don't know TypeScript, but
just like smaller bugs, people can now easily create pull requests, and if they've never done TypeScript before, they just can't.
Yeah. But I suppose we could say that about everything.
Yeah.
And we'd never move forward. We'd still be free.
Yeah, true. But it makes the learning curve a lot steeper than just using ES6, for example.
Yeah, we have the same issue at work because we're using C#, and they've gone, C# to C#4 to C#6, added a lot of nice, cool things which shorten things, much like ES6 has done to JavaScript. And every time you use that, and a new person comes in and says, "What's this?" But if we didn't start to use it, then we'd never use it.
Yeah, it's true.
Awesome. I'm about to run out of power here. So, yeah.
When are you guys planning on doing the next Hangout? Is the next Hangout the release, or?
Yeah, tomorrow at 6.
Oh, it's tomorrow.
Bring your own beer.
I've got an appointment tomorrow.
What?
I thought it's next week.
Oh,
I'm really ready. There was some issues bring by community latest time. I don't remember if we resolved it all.
Hmm?
There was some. I don't remember. There was something.
I agree. What do you mean, like an issue, an important issue on GitHub, or?
On Discord and on GitHub.
Discord.
Yeah, I'm talking to what's his name, Andre, about the render stuff.
So how the progress?
Yeah, I think it's related to, like, we created this render loop analysis thing inside the old React Vue package, which is kind of crazy, because if React changes the way things render, then that code won't work. I can't be certain, but I think that's one of the reasons. But I asked him to test out strict mode, and that improved it a lot. So that's good to get the verification that strict mode actually has a good effect. And yesterday evening I implemented the render counting in the debugger. So he's reviewing it again, because I wonder what exactly in his code is causing extra renders. I don't think it is Cerebral asking a component to update. It might be because he is passing a state from one component as a property to a nested component and stuff like that. So I just want to make that clear first. But I don't think it's an issue at all. It's like we can optimize React to a level where it doesn't make any sense to optimize anymore, and I think we are there now, at least with the strict rendering. So I'm not worried about that at all, really.
Great.
And and the render issue I mentioned, that was a bug in our code. So and we will so that's one thing I hope to implement either this evening or during the release, is this timeout on async actions.
Have you seen my proposal?
Oh, no. Yeah, don't you look at that.
I think we should introduce a timeout property for actions, so user could define manually if he expect it to fail for some time, or maybe not to obtain this timeout error. If timeout set to 0, you just don't check it.
Yeah. I think it should be on by default, because then you can catch bugs where you suddenly, we had like this chain of parallel actions.
We can have something like option when instantiate Cerebral.
Yeah.
To have some default timeout for all actions.
So is this going to be Is this going to be a property, like a static property on the action itself, like async is?
Yes, yes.
Okay.
What's the use case for timeouts and actions?
Sometimes async action fails, and you can check it because Cerebral just blinks with signal it's running and doesn't proceed to output.
Okay, but wouldn't you agree that it's most likely a service that should have a timeout?
Yeah, though there's a different issue as well, and that is if you do something wrong, like we did, we had parallel actions, and suddenly there was a colleague of mine inserted a normal action, and suddenly that action was run asynchronously because it was put inside a parallel array. And we didn't notice that, and we thought there was a bug with the debugger because the debugger didn't update. But it was because so it's to help you if you use an action that's not supposed to run asynchronously, and because of the way you have composed it into your signal, it does run asynchronously, and then you will be notified about it.
But don't you already throw an error if there's an action that's not marked as async inside a nested array?
It's only an action tree right now.
Yeah,
and
only an
is
action
not
tree.
part
Because
of
I ran into that in action tree, okay. So it's not in the core yet?
Yes.
Okay.
But yeah, but if we find something tomorrow that blocks the release, of course, no worries, but I have high hopes.
Yeah. I suppose just on the parallel action thing, it's probably where the chain builder could actually have a parallel method, and then you could pass in explicitly your parallel.
Yeah.
Yeah,
thing.
I think that's the one thing where the signal or the action chain definition is not very explicit. It's this nested array thing where you define a group of parallel actions. I think this is like this one bit where it's not absolutely clear what's going on.
Yeah, I'd almost.
If you could have like a way.
Rather see that disappear, and you have to call a function around it or something for parallel actions or something like that. Because it's too easy to do. We've done it heaps of times as well.
Yeah.
Yeah, especially when you compose.
Yeah, so I was just about to say that. When you compose, you kind of lose track of the mental image of the whole signal, and then, that can happen.
So I think we should keep arrays now in 1.0, and maybe we should
have a switch or something.
Explore chains and actions, especially chains syntax with a function calls like Adam suggests, and make it official.
Mm-hmm.
The other day I had the idea of having like a functional way of describing action chains, where you have like a method sequential, a method parallel, and so on. And then maybe write like a JSX parser that parses JSX structure, where you can define your signal structure in JSX. Would that make sense, or is that completely stupid?
It's a fun idea. Like Facebook did it with JSX.
I was thinking about that today as well when I was doing the fluent syntax stuff. How could you make this more functional? And yeah, that would be a pretty cool way to do it.
Yeah.
But even if you in Cerebral, even Cerebral 1.1 or whatever, you could have a flag that turned off the parallel thing unless you wrapped it with something. It wouldn't be a breaking change; it would just be an additive thing.
Yeah.
So almost like strict mode for signals or chains, and say no nested arrays unless you put a method called parallel around it or something that knows how to interpret it.
Yeah, and I suppose we could maybe have like one version where we warn about actions being put into parallel stuff that's missing async true, and say that, okay, you have to explicitly set it, and then for the next version we will actually throw an error as well in the current version, like in the not in the action tree version, but this version of the tree or the signal.
Yeah, sounds good.
Cool. Should we any more input or questions? That's good.
Yeah.
Thank
Enjoy
you.
the drinks tomorrow night.
Yeah, thanks. And thank you very much for putting this work into the TypeScript stuff, Adam, and showing off.
Yeah, great effort.
Yeah, really, really cool stuff. So
yeah, just probably like to echo that back to you guys as well.
yeah,
Been a pleasure to work with so far. It really has turned a lot of complexity into something that is not too bad to understand.
yeah, yeah. That's all we can hope for. I think not too bad.
Yeah.
Cool.
Cool.
Great. But okay, Alexia, do you want to handle that action point of creating the repo for TypeScript and invite Adam to it?
Yeah, I can do it today. I will create a repo. I think we should put there some. We will put there typings and reports of some Cerebral stuff, and also helpers for pass, get pass from model, and etc. And
Yep.
mark it experimental and let people try it.
Yeah.
Yeah, exactly, and we can just iterate on it from there.
So finally, it would be a package wrapper for Cerebral.
Sounds awesome.
Cool.
Cool. Thanks, guys.
Thank
Talk to you later.
Bye-bye.
Bye-bye.
Yep.
Bye.